So this is the model of the dual axis solar tracker, which is right now connected to my laptop. Now we can observe that there are 4 LDRs on the panel, which help us to measure the intensity of light in the surroundings and help us rotate the panel. Now the input from these LDRs is taken through wires into the Arduino board in the analog input ports, and with the help of 2 servo motors, one for each axis, we try to rotate this panel. So we can observe that there are 2 motors right here. The top one is for vertical axis and the bottom one is for the horizontal axis. We can also use battery to power the solar tracker. If it is connected to the laptop, we can also observe the outputs given by the LDRs and also the angle rotated by the servo motors in the screen. Now let us observe the working of the dual axis solar tracker.
Hello sir, I am Shravan. I will be doing simulation of the solar single axis solar tracker and dual axis solar tracker. Now we will be doing simulation of the single axis solar tracker in Tinkercad. This is the model. Now we will go into the code. This is the code of our single axis solar tracker. At first we are defining the servo motors and the pin connections of the LDRs and initializing the servo angle to 0 and the limit hang and 180 and 0 are the limits of the servo angles. In the void setup we are connecting the servo motor to the analog 9 to the Arduino. In void loop we are picking the LDRs and calculating the servo angle to be rotated such that it gets the maximum intensities. In the greatest function we are calculating the maximum intensity picked by these LDRs, and to find the elimination of the 2 LDRs we are using the elimination function. Now we'll start the simulation. This is the serial monitor. Now giving the one of the LDR input to the high, it start rotating to the other side. We can see this the servo angle gets increasing to 12, 13 and 14 and 15, and we are also printing the LDR values of the both LDRs and the elimination value of the LDRs and the maximum intensity picked by these LDRs in this simulation period. Now coming into the simulation part of dual axis solar tracker, in this model we will be using 2 servo motors and 4 LDRs. One servo motor is for rotation in horizontal axis and other one is rotating in vertical axis, and we are using the 4 LDRs, one for the top right and another one to the top left, another one to the bottom right, and last one to the bottom left, and we'll be using the 4 resistors of 10 kilo ohms. Now coming into the code part, at first we'll be defining the servo motors and their initial angles and their limits. In setup part, we'll be connecting the uh, 10th and 9th pin analog pin of Arduino to servo motors. In while loop part, we'll be taking the values of the LDRs and calculating their averages, average top, average bottom, average left, average right. After that, we will be calculating the servo angles for vertical axis and horizontal axis to be rotated such that it will get the maximum intensity. And we are using the greatest function to calculate the maximum intensity picked by these 4 LDRs. And other And last function is elimination to find the elimination of the four LDRs. Now we will see. Coming to the working part, we can give the input here. We can see that the both horizontal axis and vertical axis servo motors are rotating to an angle such that it will get the maximum intensities. These are the outputs. In the outputs, we'll be printing the elimination of the four LDRs and the average values and vertical servo angle to be rotated to get the maximum intensity and the horizontal servo angle and the maximum intensity.
I'm Manish. I'll be doing simulation of triple axis. As we can observe, there are 3 servo motors and 6 LDRs. One is horizontal servo motor, vertical servo motor, and other is combo of vertical and horizontal servo motor. And the 4 LDRs are placed same as in dual axis: top left, top right, bottom left, and the remaining 2 placed at the center. One is at the top, one is at the bottom. Coming to the code, here first we are defining servo motors and assigning maximum and minimum values to servo motors, that is 0 and 180. Here we are assigning analog pins to LDRs. Coming to setup part, we are assigning digital pins to servo motors 9, 10, 11, and initializing all 3 servo motors to 20 degrees. In loop part, we are reading the values of servo motors and LDRs. Here we are calculating the values of LDRs and rotating the servo motor according to the condition. Here we are printing the values of servo motors. In this maximum function, we are finding the maximum intensity of LDR. Coming to simulation part, as we can see, the all three servo motors are changing their values, and we can see there is a maximum intensity of 974.